Okay, today we're going to be talking about solving by factoring. And what I really want you guys to get out of this lesson is that quadratics can have solution, two solutions, or no solutions. Now, quadratics are of degree 2. So if you have anything higher than degree 2, then you will have more solutions, or you have the ability to have more solutions. So how to use the zero product property is also going to be super important to solve by factoring, and that every quadratic can not be solved by factoring. So we will need to make sure that you have more tools than this, but this will be our first tool. So the zero product property basically says if you have a product equal to 0, then one of the factors, or I should say, if a factor is equal to 0, then it'll work. Because if I have two numbers that are or two values that are multiplying by 0, one of them has to be 0. So either A is 0 or B is 0. And anything that makes A 0 will work, and anything that makes B 0 will work. Okay? This can only happen if we have 0 on one side, right? So that's super important. Because if we don't have 0 on one side, we're not having a product equal to 0. All right, so just a little checklist to solve by factoring. We need to get that 0 on one side. Then we need to factor the other side if we can, and if we can't use this tool, right? And then set each factor equal to 0 and solve. Okay. And then a little side note, no solutions come from a factor that does not have a variable, because obviously we're trying to find a variable that will make this happen, make this product 0. So if we have a factor that doesn't have a variable, we're not getting any solutions from that. Okay, so our first example already has 0 on one side, and it has 1, 2, 3 factors. But we see that the first factor doesn't have a variable. And we know if we set that factor equal to 0, that's not going to make any sense because it's not equal to 0. It'll never be 0. It's a constant, right? So we don't worry about that factor. We only worry about the factors that actually have variables. And we set each one of the factors that have variables equal to 0. Okay, so now once we have each factor equal to 0, we solve them, subtracting 2. So x is equal to -2. We add 4. So x is equal to 4. So in this situation, the two x values that will make this true are -2 and 4. Notice how this is not an ordered pair. It is a list of values that will make the solution, or make the equation balanced. Okay, so our next one, we see it has 0 on one side, and everything is factored, and we have 3 factors. Now, notice that if I took these factors and multiplied them, 3x times 2x, and then I multiplied by x, this is going to be 6x cubed, which means this is a cubic, not a quadratic. So we can have more solutions if it's not a quadratic. We could have more. So let's set each factor equal to 0. Each factor has a variable. So we're going to set each factor to x minus 3 equals 0, x plus 5 equals 0. And now we're going to solve. Dividing by 3. So x is equal to 0. Add 3. 2x is equal to 3. Divide by 2. X is equal to 3 halves. And then subtract 5. Cool. So now x is equal to -5. So in this situation, we had 3. Now, again, why did we have more than 2? Because this was not a quadratic, right? The highest exponent would be 3, so this is a cubic. Okay, finally, our last one in this row, we still have 0. What was nice about this row is they're already factored, right? So all we're going to be doing is we already have 0, and we already have the factors. So in this situation, we're just going to be setting the factors equal to 0. Some people get really thrown off by this because they're like, wait a minute, this is too easy. I must be doing it wrong. No, this is right. It's pretty easy. You guys will do fine on these. Okay. Again, a little bit of a reminder that on the examples, it's best if you try it on your own and then play the video and see how you did. Okay, Example 4 obviously has the very first problem is that this is not 0. So the first thing we're going to do is going to make 0 on one side. 2x squared minus 5x minus 12 equals 0. Cool, cool. Well, notice that this has the highest exponent of 2, so it is a quadratic, so we should have up to 2 solutions. When we factor this, also notice that this 2 tells me that it is not a simple polynomial, so we are probably going to either use the box or we're going to expand the third term to make 4 terms to factor by grouping. I'm going to go ahead and expand that term. So I need two things that multiply to negative 24 and add, because we're expanding it, to negative 5. So as I think about this, I can see that we're going to need a negative 8 and a positive 3. Those multiply to negative 24 and they add to negative 5. It might have taken you a little longer to get this, but it's okay. The more practice you have, the better that you are going to be. Now our two values are negative 8 and 3. I would always put the negative 8 first and the 3 second. But in order for these two things to add up to a negative 5x, they would have both had to be x terms. Cool. Now we have 4 terms, so we can factor by grouping. When I look at the first set, I know I can take a 2x out, and I'll be left with x minus 4. When I look at the second set, I know I can take a 3 out, and I'm left with x minus 4, which is good because I needed to be left with the same factor, right? So that when I look at the whole group, I can see that x minus 4 is in common, and I'll be left with 2x plus 3, 2x plus 3. Okay, so now I have my two factors equal to 0, so I'm going to set each factor equal to 0 because this can only happen if one of them is 0, has the value 0. So what would make the first value 0? It would be 4. So x would equal 4. 4 would be one of our solutions. Subtracting 3 from both sides, we see that 2x is equal to negative 3. So when we divide by 2, negative 3 halves would be another solution. Let's just write that out so we have it. Okay, now let's look at our next example. Our next example does not have a 0 on one side. So as we're looking at this, we're like, okay, I'm going to tell you that if I have my squared term positive, I'm going to leave it there. I'm going to leave it wherever it is because I would like that to be positive when I'm factoring. So I'm going to subtract 17x and subtract 28. Now, you could have added subtracted the negative, or subtracted 3x squared from both sides and then multiplied everything by a negative. It's totally up to you. But you do need to get 0 on one side, and it's best to have the squared term positive. Okay, so now I see that not all 3 of them have something in common, so I'm going to expand this negative 17x so that I can have 4 terms. And so we know that this is going to happen when we add to negative 17x. So to get our product, we multiply the first times the last, and that's going to be a pretty good size number. So I'm going to take this 28 and I'm going to break it down to 4 and 7, which is 2 times 2 times 7. So altogether I'll have 2 times 2 times 7, but I'm also going to have a 3, and I'm just going to write it a little bit differently. But we have to remember that this is negative. And so our product is negative, so one is going to be negative and one of these is going to be positive. So we're going to take something and then subtract it from something to make the negative 17. So let's see some ways that we could do this. We can have 12 and 7, but 12 minus 7 is not negative 17. So guess what? That is not going to be the way we go here. Okay, what if we make 21 and 4? Leaving the 21 is going to be biggest because when we subtract, we want a negative 17. So, well, good job, you guys, because that works. And I'm going to put my negative 1 in the front and my positive 1 in the back. And remember, these have to add to as negative 17x, so they have to be like terms. All right, let's factor by grouping. So we'll take a 3x out of this one, and we're left with x minus 7. And remember, if the front one has a negative, you have to take a negative out, but ours is not. So we'll take a positive 4 out, and we'll get x minus 7. And then that's fantastic because they match. Because when I go to get a common factor out of both groups, we're going to have x minus 7 as our common factor, and then we're left with 3x plus 4. So now we have 0, and we have it factored. So we're going to set each factor equal to 0. So we have x minus 7 equals 0, and 3x plus 4 equals 0. So we'll add 7 and get x equals 7, and we'll subtract 4. 3x equals negative 4. Divide by 3. And guess what, guys? We have our last solution, which is x equals negative 4/3. So our two solutions will be 7 and negative 4/3. Okay, let's move on to the next one. Again, our next one has 0, yes, okay. But now we need to factor the other side, and the first step to factoring is seeing if there's a greatest common factor. We see that they all have a 3, and they all have an x, so we'll take that out first. And we'll be left with x squared plus 5x minus 24. Okay. So now we already have this factor, but we know that we're going to need to factor the other trinomial, but it's simple because there's a 1 here. So we know that we're going to be just putting our magic numbers into the factors. So we need two numbers that will multiply to negative 24 and add to 5. Well, again, we have a negative, so we have a negative and a positive. We are adding to a positive 5, so the positive will be bigger. And sometimes I even circle that just to remind myself that that has to be the bigger number. Okay, so what makes a 24? Well, a 24 can be 2 times 12. Well, 12 minus 2 is not going to make a 5. It can also be 4 times 3. 4 minus 3 is not, sorry, not 4 times 3. 4 times 2 times 12. Okay. 4 times 6. And 6 minus 4 is not going to make a 5. And then 8 times 3, and 8 minus 3 will make that 5. So we'll put the bigger number here and the smaller number here. So we'll get x minus 3 and x plus 8. And we have that 0. So now we'll set each factor equal to 0. And solve. So to solve this, we will divide by 3. X equals 0. On this one, we're going to add 3. X equals 3. And the last one will subtract 8. All right, so we have 3 solutions. And remember, why do we have 3 solutions and not just 2? Because this was not a quadratic, right? This was a cubic, so it has the chance to have up to 3 solutions. Okay, so now we're going to go backwards. Now I'm going to give you the solutions, and you tell me what polynomial it could be. Okay, so I want you guys to think backwards here. Well, right now we have x equals 0, x equals 3, and x equals 5. Those are our solutions. Well, we needed the factors, and each factor, in order to make my polynomial that's equal to 0, would have to have 0 on one side. The first one already has 0 on one side, so we have x. And the second one does not. So let's get 0 on one side, and you'll see that x minus 3 will equal 0. So x minus 3 is the next factor. And then again, no 0, so we need to make 0, and we'll get x minus 5 equals 0. You can kind of see how we're moving backwards. Well, we still don't have a polynomial. We do have the factors, but we don't have a polynomial. So what we can do now is we can multiply these together. Let's move this up a little. I didn't need as much room. And so we can do it either way, but I'm going to go ahead and multiply these two first and get x squared minus 5x minus 3x plus 15. And that's still times x, but I'm going to simplify this a little bit. So we have x squared minus 8x plus 15 equals 0. And then lastly, I'm going to take that x all the way through. So x cubed minus 8x squared plus 15x is equal to 0. So if we were needing to write this as a polynomial, and I would even say polynomial equation, right? If I just needed the polynomial, it would have been x cubed minus 8x squared plus 15x, right? So that polynomial would have these solutions or things that would make it equal to 0. But if you wanted to write it like this, I'm perfectly okay with that. Okay, I hope this helped.